Hello, everyone. Thanks for joining us today. We are just about ready to get started here. On behalf of the Environmental Finance Center Network, I'd like to welcome you to today's webinar, Ask the Expert Style webinar on mapping for water loss and asset management. My name is Tess Clark. I work here at the Syracuse University Environmental Finance Center. And I'm just going to go over some logistics before we get into the meat of our program. So the first thing I wanted to let you know is about our logistics of this session. We're going to be doing a question and answer style format. So it's especially important that you take advantage of the question dialog box on your GoToWebinar dialog panel. You just type your questions into that box at any point, and somebody will be lining them up and keying them up so that we get every single question answered, hopefully. And if we don't make it to your question, someone will follow up with you. On a related note, everyone will be on mute just to ensure audio quality. And I wanted to also let you know that part of the session will be spent addressing some of the major questions we received when you all registered. So that will be done first, and then we will get into the extended Q&A. So again, make sure you enter your questions into that box, and we will get to those as we go through the program. We will be making today's slides available as well as a video recording on our website. You can reach that website at www.efcnetwork.org. Please allow 2 weeks for the processing and posting of these materials. As a courtesy, we like to provide a certificate of attendance for participating in our webinars. However, we don't submit these webinars to licensing agencies for pre-approval of continuing education credits. You will need to check with your licensing agency directly if you are interested in receiving formal credit. You must attend the entire 60-minute session by logging into GoToWebinar with your unique registration link in order to receive a certificate. And if you watch the webinar with a friend or you're not directly logged in, we won't have a record of your attendance. So you'll need to make sure that you are logged in, because otherwise we can't get a certificate to you. For those of you that do attend and would like a certificate, we will email those out to you within 30 days. Now a little bit about us. This session is one of several webinars that we conduct here at the Environmental Finance Center Network for our Smart Management for Small Water Systems project. Through this project, we provide training and technical assistance to small public water systems in all 50 states and territories to help local systems achieve their goals and stay in compliance with the Safe Drinking Water Act. And here you can kind of take a look at our program team. You can see that our network is national, and we have centers based everywhere from Syracuse to Sacramento. And here you can see the areas of expertise that we focus on. So, as you know, we do asset management and rate setting and fiscal planning. You'll hear about asset management and water loss reduction techniques today. But keep in mind, we also focus on resiliency and managing drought and other topics as well. And on that note, I'd like to introduce our presenter, James Markham. James is a research scientist at Southwest Environmental Finance Center at the University of New Mexico. So James, I will let you take it away at this point and get the ball rolling.
Okay, I have to, let's see, here we go. All right, screen should have changed. So thanks for joining. With me here today are Luke Andrews and Haley Hajic, who are also research scientists here at the Southwest EFC. We're talking about mapping in the context of asset management and water loss reduction today, and I want to start with a disclaimer, and that is that you'll see and hear about different pieces of software and different pieces of hardware today, and I want to make it very clear that we are not specifically endorsing any of these products. These are just examples of tools that we use and have found effective. There are a lot of other ones out there similar to the things we'll show you that are just as good. And if you ask us, we will not tell you what to buy, but we can give you factors to think about when making your choices. As Tess noted, we did get several questions as part of the registration process, so we're going to start with those. Haley's going to be monitoring the questions that come in over the board as we're going along, and we'll do our best to answer them as she feeds them to us. If there are questions that we can't answer or that seem out of the scope of today's talk, we will be sure to answer those offline, and we'll make the answers that we do give available to everybody who attended the webinar. So, and also just depending on the questions that we have, we may be switching screens. We've got a couple of little demos that we're going to run. And so please bear with us if there's some little hiccups during the screen juggling piece. So that leads me kind of to the first question that we got. And just sort of in general, I want to talk about, mapping is really kind of a process that you should think about. And it really involves planning first and foremost, deciding what information you want to collect, the tools you want to need, tools and software you're going to need, and what sort of a time frame you're working with. It's the whole sort of, measure twice, cut once kind of approach. The more effort you put into the planning phase, the more successful your mapping project is going to be. Then obviously you need to go out and collect that data. And we'll talk later on a little bit about the kinds of data that you'll want to collect. We're going to have a fairly heavy emphasis on GIS-related tools today because they're really useful for combining data sources, pulling them together so that you can take a lot of different parts and come up with a sum that's greater than or a whole that's greater than the sum of the parts. Obviously, proofing data is really important. There's always going to be conflicts. A lot of the data that you're going to be using won't necessarily have been developed specifically for mapping. That doesn't mean it's not useful, but it is really important to proof your data, to retain a record of what your sources are and how accurate they are, because once things get written down, they have a tendency to be treated as gospel, and the last thing you want is somebody making incorrect assumptions later on about data that you collected or analyzed today. And then finally, and most importantly, this is really about making maps and using them and improving them. We've dealt with a lot of utilities, and when we talk to them about their maps, it turns out they're rolled up in a nice tube in the corner of the office so it doesn't get damaged. And that is definitely not the way to approach mapping and maps in general. There are tools that should be used and improved. So with that sort of brief introduction, our first question was from an attendee in Oklahoma who asked, how easily can mapping be used in conjunction with water loss reduction to create a leak log or other record of line breaks? The short answer to that is fairly easily, actually, if you've got the right tools. And so we're going to show you a couple of tools that we use for this. Let me switch screens here briefly. So what you see here on the left is the web interface for a tool that we use called Fulcrum. There are others like this, but essentially what it is, it's a data collection tool that you can use to build applications. And what you see on the right is a screenshot, and will shortly be a video of an actual data collection process to kind of give you an idea of how easy this actually can be. In the context of mapping water breaks, one of a really good tool out there is the Water Research Foundation's Project 4372 Leakage Component Analysis Data Collection Tool, which is essentially a spreadsheet format that is set up to capture all the critical data that you need for calculating water loss. And what I've done, because an Excel spreadsheet is great for analysis in the office, but maybe not the best data collection tool, is I've essentially translated that tool into a web app that I can use on a tablet to collect data in the field. And so if you look at the left side of your screen, what you'll see here, we've got a layout field, we've got fields on the left that we can add. So I've got the failure type of event, and I've got essentially different classifications here. We've got different fields for report time, failure time, the piping material, because quite often you don't know until you dig the hole what kind of pipe you're actually dealing with. This particular app, if you're in an urban area, will autofill an address for you. It automatically collects GPS coordinates. And the nice thing about using an application like this is that you get uniform data, and it's very easy to set up an SOP so that your data collection is standard. One of the pieces that the Water Research Foundation tool doesn't include is a field for photographs, because it's an Excel spreadsheet, but I think photographs and video, particularly in a leaks environment, are very important. So you'll notice down here at the bottom, I've added a field for photos. And just to sort of show you how this interface works, if I wanted to add a field for videos, I would literally just drag this down here, and that would be added in. I can add a description and save that. And once I've saved this and exit and update the tablets by syncing them, all of those would have that information on them. What I'm going to show you here on the right, really briefly, is me sitting in my office doing a data collection. So that's actually where we are more or less right now at the University of New Mexico. And this is a screen grab from the iPad, which is one of the tools that we use for data collection. And so the first thing I would do is hit that bottom X. It brings up the app, and I start filling in the information. So it's maybe this particular thing was reported by a complaint by a customer. I've got category of failure, the failure report date. Say that was the day before yesterday at 2:30. When it was pinpointed, that's important from operational standpoint. When it was contained, that's important for water loss, pipe material. I might as well collect that while I'm there. Soil conditions, particularly with metallic pipe, can be very important. You'll notice the address it filled in automatically. I've left a few things blank, estimated repair costs, flow rates, because maybe I don't have that information in the field, but I can put in information about the type of crack, the size of main, and maybe the type of failure. And since obviously I'm sitting in my office, this is me taking a picture of a broken pipe. But that kind of gives you an idea of how you could go about collecting the data. And that red dot there represents that data point I just saved. We're now going back into that data record. I could be perhaps in the office and adding some additional information in. For example, the age of the pipe, and you'll see I make a mistake here. Cast iron pipe is highly unlikely to be 20 years old, but let's say 60 years old, maybe pressure, and the suspected cause of failure. The nice thing about using an app like this, again, uniform data, it's a very simple tool. It's an interface I think that we're all fairly used to dealing with, tablets, cell phones, things like that. And this is a relatively inexpensive app. I think it costs about 25 bucks per user per month. So this could be used fairly easy to do some data collection relating to break records. And the nice thing about this is you'll see shortly, because Luke's going to do a demo of taking this data and actually converting it into a map, is that you can export this data in all sorts of formats. So one of those formats happens to be Excel. So I've literally just put the first entry for a leak log into place. If I export this into Excel, I can do various kinds of analysis with that. And to show you how that works, I'm going to hand things over to Luke now. I got to find his name on this list here real quick. And he will show you with a different set of data, sort of the download process. So take it away, Luke.
All right.
All right.
Are you getting my screen there?
We are.
Okay. So we've gone into the field and we've collected all of the data that we want to use in our map. And now we're back in the office and we're looking at fulcrum here. So you can see it will tell you who actually collected all of that data and when, and how many records and how many contributors you have collecting that data. So let's look at the data we collected. So down here we have the actual attributes of the data. Here, let me move that around, see if I can get it to, there we go. Show you the actual map there. So you have a map view on top that is useful for proofing the GPS of the data. If you know where some of these things are supposed to be, you can just quickly see where the points ended up. This is from one of the trainings we put on in Las Cruces recently. And on the bottom half of the screen, you have all of the attributes of the data that you collected. This is a reflection of everything that you saw in that format template builder that James was showing you just earlier. So you can verify that all of the data was collected appropriately. You can view all of the photos that were taken of each asset. And of course, you can also download the data. which is available to you in a number of different file formats, CSV and XLSX if you want to see the data in a tabular format in Excel. The shapefile.shp file format is the one that Esri products like ArcGIS Pro and ArcMap like to use. And this KML file is the file type that Google products like Google Earth and Google My Maps like to use. And these are the two that we're going to be working with today. But before we get into that, I want to mention too that if you went and downloaded this data set as is, you would get every asset you collected all into one giant data set. And you can see we have meters and valves here. And for the purpose of mapping them, we want to actually keep that separate. And so the way we do that is we come in here to the asset field, say select specific values, and in this case, we'll just say valve. And that only shows you all of the records that have an asset type of valve. And then when you go to download the data, you are downloading only your valves. So that's the way that mapping software like to split things up, is by layers like that. So I've already downloaded some of this data, and let's look at using Google My Maps to map some of it.
And while Luke's pulling that up, I just want to note for anybody that's looking at those data fields, obviously that's a very short set of data fields because it was a training exercise in real life in a production environment. There would be a lot more fields that you would be collecting data on.
That's absolutely correct. This is a much more simple version designed just for training. So one of the benefits of using Google My Maps is that it's completely free, browser-based software. So you don't have to download or pay for anything in order to do this. You go to Google My Maps, create new map, and it should open up a blank map with no data in it. We can change our base map here if we like. Let's just use some satellite imagery, why not? And you can see it starts us with an empty data layer here. So in order to populate that, we're going to say import and bring some data into that layer, namely the data that we downloaded from Fulcrum. So we'll browse to that. Like I mentioned earlier, the KML file type is the one that Google products like to use. So we'll grab those valves.kml, open, and it's loading those into the map. So we should see them show up soon. All right, so it zoomed us in on where our data went. These are a bunch of valves here. And if you click on each one, you can see that it does store all of the data that you collected about a given asset in Fulcrum when you were doing your initial data collection. You can change the style of the symbols individually by using the selector here, or you can use this to apply styles based on values from within the attribute table. So if you wanted all valves of a specific type to be given one symbol, you could do it that way. If you want to add more data into your map, you can click the Add Layer button there. If we wanted to bring in our hydrants, for example, on this example, we're just going to stick to the valves. If you hit Preview, it will show you what the map would look like if you sent it to someone and they were to see it in the view-only mode. And another useful thing about the Google My Maps is how easy it is. Actually, before we get into that, I want to mention first that you can also draw polylines in here as well. So if you had a user who was familiar with the way the system worked, you could draw the water lines in after collecting the point data in the field like so. And then name that line and record whatever information you wanted about it. And then once you feel like you've gotten your map to a good point, you can share it with other members of your system. Share button, give it a title, just say test for now. And it gives you this link. You can email this link to someone, you can text it to them, and when they click that link, it will open up their web browser to this map, which is really useful. And another nice thing about the Google My Maps is that just like when you use Google Maps for directions, you get a nice little blue dot that is your current GPS location. So you could send someone this map, they can pull it up on their cell phone. It uses the cell phone's GPS, it tells them where they are in the map, and even a newer member of your system that's not as familiar with the location of your assets would be able to use that to go into the field and start field locating things pretty easily. So now we're going to look at the Esri product ArcMap and see how we can map that same data using this. As far as more serious mapping software goes, there are essentially two industry leaders. You have Esri's ArcMap, which is a paid product and arguably the easiest one to use. And you also have QGIS, which is a free and open source version, but has a slightly steeper learning curve. And if we have time, we'll get into that a little bit more later. But I've started out, I already brought in a satellite imagery base map here. We can add in other ones or change it if we wanted by going to add data, change base map. But we're just going to stick with imagery for now. And we're going to add in some data. And now we're going to be looking for those shape files that we had earlier. Where are we here? Yep, so the shapefile is what Esri ArcMap wants to use. We'll bring in our valves layer here, add that data, and there it is. So let's zoom in to where our data actually is. You can see our points are here. It's going to be a lot of zooming coming from space. Zoom, zoom, zoom. And there's our data. And I'm just going to show you a few really quick ways of symbolizing this, just to show you how easy it is once you've actually generated that data. So one thing we can do is open the layer properties, go to the symbology tab, and we can apply a single symbol to the entire layer if we want, or we can split it into categories and have it look for data in the attribute table and use that data to symbolize it. So let's look at the valve condition and use that to symbolize it. We'll say add all values, which brings in all the values from that field. You can see that we've given these condition ratings of good, fair, and poor. Let's make fair yellow here, up that size a bit. We'll make good is going to be blue. And poor is going to be red. We hit apply, and there you go. You have your valves visualized by their condition rating that you assigned to them in the field when you did field data collection. Another way of doing this, applying symbology, is using a custom .lyr file, which I've made for this purpose. So we'll import symbology that way. And you'll see that this allows us to apply symbology in a way that allows us to use custom symbols based on the valve type. So we'll look in here and give it the asset type field to look at, where it's looking for valve type. And so this is how this works. Everywhere it finds the value ball in that field, it will apply that symbol. If it finds butterfly, it will apply that symbol, so on and so forth. So we'll apply that to our layer, and you can see our symbols have been applied based on the type of the valve. Let's just really quickly bring in our hydrants layer as well and symbolize, oh, we just have the meters, we'll do that. And we'll symbolize these really quickly as well with imported symbology. Meters, add, okay. And there we've got a nice meter symbol on there. So just to show you how quickly and easily you can go from collecting data in the field to mapping that data and symbolizing it the way that you want to. There's, you know, an infinite number of possibilities of how you could choose to symbolize that data. So you're going to have to decide what's meaningful to you and to your system. But these software packages give you a lot of power and freedom to do that, and it can be done fairly easily and fairly quickly. So that about wraps up our mapping demonstration. James, if you want to take it back.
I think now would be a good time. We've gotten a couple of questions referring to fulcrum and ARC, so I'm going to ask you guys a couple The first one, going back to when you first started showing the fulcrum map, James, people are wondering if they can get a copy of that spreadsheet that you created within Fulcrum, or is that something that they have to build?
So the Fulcrum app, if you have Fulcrum, we can basically send you the template for that. That's one of the nice things about Fulcrum. If an app has been built and you know a user who's got it, you don't have to remake the wheel. I think they might actually be referring to the Water Resource Foundation spreadsheet, however, which you can find on their website. If you do a Google search for Water Research Foundation Project 4372A, that should pull up a link where you can download. And it's actually a two-part package. There's the piece of software to collect the data in, but then it's also got a leakage component analysis model that is also Excel-based that I'll talk a little bit more about in a few minutes, but that you use in conjunction with the AWWA's M36 water audit software to do some analysis based on data collected as part of the audit process. So I think that answers that.
Mm-hmm. Next would be, can Fulcrum, any Fulcrum product be integrated with ArcGIS or Esri products in general?
There is no direct integration at this time. It works with those products fairly well. As you've seen, I was able to take data from Fulcrum and bring it into ArcMap in very little time, but there is not a direct integration for those two products right now.
That being said, you know, Esri does have a lot of its own data collection tools like Collector that function in a somewhat similar manner that you can use to build similar applications and do a direct type of integration.
So the next one, I know, Luke, you showed some symbology options for ArcGIS, but the question is, are there symbology options within Google specific to utilities that would show, say, a fire hydrant, or did you make up that symbology?
Yeah, so unfortunately, Google is pretty light on having a lot of icons available to you right away, because this isn't necessarily intended for the purpose of mapping a utility. So the short answer there is no, and the long answer is that you can use your own custom symbology through the custom icon and import an image and use that as the symbol. So if you found symbology you wanted to use elsewhere, you could use that this way, or you could make it yourself, but unfortunately it is not natively available within Google My Maps.
Yeah, and actually when we were out in Wisconsin and looking at some of the maps that some of the attendees were showing us, several of them had done Google My Maps and for some reason had used the little bomb icon for the brakes. So, you know, obviously it's not that difficult to do, but it does take some work.
Mm-hmm. So maybe last question for now, this will be at you again, Luke, talking about projections within ArcMap. Are there projection concerns when bringing GPS data into Google or ArcMap, say WGS 84, if the data is GPS in a state plane coordinate projection?
Yeah, so every piece of data that you collect using GPS is created using WGS 84 because that is the coordinate system that the GPS devices themselves use. It shouldn't inherently create problems for you, but if you are, it shouldn't inherently create problems for you, but if you're using a different projection in ArcMap, a lot of the times it will reproject on the fly, or you can use the define projection tool to change it to the one that you're using for the rest of your project. But that's basically the industry standard for what you're going to get out of any GPS data collection is WGS 84.
Okay.
I just noticed a couple other questions. There was one, how can you convert a spreadsheet file to a KLM or shapefile? Assuming that you have actual GPS coordinate data in those, you know, Esri, as part of the import process, you can define, if you're bringing a table in, you can define in what are your X, Y, and actually Z coordinates if you happen to have an elevation, and do it that way. I'm not sure about on the KLM side.
There are tools within the ArcMap program that can be used to perform that conversion. And while I haven't used them myself, there are also online converters as well. So if you Google search that, or if you already have this ArcMap program, you could look in the Arc toolbox. But there are converters that you can use to just straight up convert the file type from one to the other.
Yeah, and same goes for QGIS. There's a lot of, QGIS is an open source project, so there are a lot of tools that people have created as they need that are out there. One of the things that Luke mentioned was a little bit of it being a little bit more difficult because there's a slightly steeper learning curve. And unlike Esri, not all of the tools are sort of prepackaged with the product. Sometimes you might have to do some searching to find them.
Well, we did get a couple more questions in. If you want to continue with questions, or would you want to save them for a little bit later?
Yeah, let's continue with the questions.
Okay. So how well does Fulcrum integrate with a work order and or an asset management system?
Well, Fulcrum really isn't designed as an integrated tool. It's kind of a standalone data collection application. So I would say that you're not going to be able to necessarily directly integrate it, but you could develop processes for taking the output files from Fulcrum and converting them and potentially pulling them into your other system. It's really meant to be kind of a one-size-fits-all kind of tool. The other thing I should probably point out is that Fulcrum is great for point data and events, but it's not very good for example, putting in linear assets like pipelines and things like that. It's really more for a point data application. So yeah, again, like with the Esri question, not direct integration. That being said, I've seen a variety of small systems and other organizations develop SOPs that allow them to pretty smoothly collect data, proof it, and then pull it into their respective mapping systems or other kinds of systems. So it's basically all ones and zeros. There's a lot of different formats, and if you've got things in a tabular format, you can usually convert it into a database format if you've got the right tools.
There are also many asset management software that either integrate ArcGIS or are based. The platform is ArcGIS, so I think that if you're interested in Fulcrum versus ArcGIS for asset management software and work orders, I would go more with ArcGIS just because it's a little bit further along.
Oh, one more question about Fulcrum. There was a question about field units. I noticed that there were no field units in the data input in the screen in the demo I did, and that is correct. That being said, all of the descriptions and titles for all of those fields are customizable. And what we've typically done is, where it says main size, I really should have put main size in inches diameter, things like that. So you really have to kind of build those instructions into the longer descriptions of the fields, but you can also have sort of a help function there where people can click on an information tag for that specific field, and it will give them additional information about what they're supposed to put there. Again, this sort of goes to the whole doing a lot of planning and setting things up well before you actually get out into the field, because I have seen a variety of situations where people have used, top quality survey grade equipment to collect, sub-inch point information, but because they haven't really thought through the other attributes that they want to collect, when they get back to the office, they don't really have all the pieces of information they need to do the analysis that they want to do.
So another question, this one for you, Luke. Does Fulcrum support external GPS receivers?
It does, and that's what we use when we go into the field, is we Bluetooth connect the device that's running Fulcrum, in our case, either a cell phone or tablet, to an external GPS receiver. We use a Bad Elf GNSS receiver for that purpose and just connect it via Bluetooth, which is advisable because the GPS native to a cell phone or tablet is likely not accurate enough for the purpose of mapping your system. Going back to what James was talking about, an external GPS in the price range of $200 to $500 that's going to get you within 5 or 10 feet of the point is likely accurate enough for this type of mapping. But yes, it does support external GPS receivers.
And on that topic, a lot of the mapping, for example, related to brakes, in some cases you're going to want to know exactly where that is, but if you're trying to do sort of a condition analysis, for example, I have some images here that I can show you. Let me pull the screen back here for myself. You know, GPS data collected for brakes in the field will often not be exactly on top of the pipe, and that's quite all right because you can. So this is, for example, is a town in Illinois, and what the data came in originally, it looked like this. Hold on, let me get my screen to function here. The actual breakpoints that they had were where those red X's are, and those obviously aren't on the pipe. There are tools within ArcGIS and QGIS and other GIS programs that will allow you to shift things over. So what I've done here, if you'll see, there's a corresponding black dot with each of those red X's, and I've basically used tools inside ArcGIS to shift the breaks to the nearest point as long as it's within a certain number of feet so that I don't get weird results. And then by essentially joining the two layers together, I can get a count of the number of breaks on a particular piece of pipe, which is what we have actually got shown here in this screen. Basically anything that's green has 4 or less breaks. The things in orange are somewhere between 5 and 9 breaks, and the red points are pieces of pipe that have 10 or more breaks, and then those are coded based on the thickness is based on the number of breaks you have. So this is sort of a very quick and dirty analysis of an entire network's condition based on the number of breaks that have occurred on various pieces of pipe. And you can see that although there are breaks distributed throughout the entire system, there are some pockets that are extremely problematic. For example, in the bottom right-hand corner, that particular piece of pipe has 25 breaks on it. So there are a lot of tools that you can use to sort of get around the potential accuracy limitations of some of the GPS uses your GPS devices you're going to use. And again, it really, what equipment you use and how you do the analysis really depends on what kind of questions you're trying to answer.
Okay, great. Well, the last question we have going right now is, are there any grant funding available? Is there any grant funding available for GPS, digital meters, and mapping like this?
I believe there is in some states. I mean, it really varies. I would check with the state revolving funds for drinking water to see what they're supporting. I know some states do provide some funding for asset management planning, and this type of equipment might fall in that category, although I cannot be sure. I do know that some states in the Midwest have paid for new meters, for example, and since asset management planning is often a condition of certain loans, it might be possible to build in some funding for the tools you need to do that. That being said, the tools that we use for this, and we've mapped a lot of small systems in New Mexico, you know, we're using a GPS unit that costs about $450 and a cell phone that we already have in our pocket, you know, before we actually bought specific tablets, you know, and these will run on Android, they'll run on iPads as well. So you could essentially get a fairly robust data collection system together for less than $1,000.
And if there are any tribal water systems on the line currently, they do offer ArcGIS that is funded completely for you, and I would absolutely take advantage of that because it's a state-of-the-art system and it can be fairly expensive. So if you are a tribal water system, I would look into that.
Oh, and you get that through the Bureau of Indian Affairs branch of geospatial support. So that is what you would want to search for when looking for that.
And There is a similar tool to Fulcrum that is designed specifically to work with QGIS, which is a free open source GIS program. You know, if you're interested in getting involved in GIS and don't have the budget you might need for Esri licensing, this is definitely a way to go. It's called QField. I'm not sure if it's quite as robust as Fulcrum or ArcGIS Collector, but it is out there and it is being worked on constantly, because again, it's an open source project and there are people around the world that are doing development. The one downside of QField is that it currently, at least as of a few months ago, only worked on Android devices. That being said, Android tablets are fairly inexpensive to buy. You could probably get a Kindle Fire for $50 these days that would run the program.
So that's all the questions we have thus far. I encourage you all to continue to ask questions, and James is going to pick up the presentation wherever he chooses.
Okay, well, the next written-in question was from a system in Washington that was looking for a better way to estimate and quantify distribution system leakage. This is a little bit of a hard question to ask because I don't know what the system is currently doing, so I'm going to answer this in a little bit more general terms. And I would say that step one is to actually do a water audit, even if you're a small system. I know Washington recently, I think it was last year, ran a pilot program with some of the larger systems, and they're, like many other states, are getting heavily into the water auditing world. And for those of you who aren't familiar with that, what it is essentially the water audit software is an AWWA developed Excel-based piece of software that lets you do a top-down analysis to quantify your real and apparent losses in your system. And essentially the way it does that is that you try to account for measured and estimated system inputs and outputs, and assuming your data is good, and after you've corrected for meter error and things like that, what's left over is real loss. Doing an audit alone can give you a fairly good idea about whether your distribution system real losses are actually a significant problem or not. It's important to point out that that volume is never going to be zero and obviously can't be negative. You can't get more out of the system than you put into it. I think it's important to note that the M36 Audit is a good piece of software, but it is not perfect. It gives up some accuracy for ease of use. The results are not perfect, and it's difficult to quantify how off they are, like a margin of error, because it does a qualitative analysis instead of a quantitative analysis. That being said, it's a very, very good tool, and it's an even better tool if you use it in conjunction with the Water Research Foundation Project 4372 leakage component analysis model, which basically allows you to take the break data that you've collected either in their spreadsheet or using a fulcrum app like this or using another tool and sort of plug them together to do a bottom-up analysis. So where you're basically looking at the breaks and leaks in your system and quantifying the volumes that are lost and comparing those results to the results of the water audit and sort of using those to calibrate. It's also important to recognize that in many systems, particularly older systems, background leakage is going to be a very large component of your overall leakage, and it's often leakage that you cannot find using modern acoustical methods. If you've got a district metered system where you can compare meters in different sections of your system, that's a little bit easier to find, but there is always going to be some amount of leakage, particularly in older systems, that you're not going to be able to find. And it's also important to recognize that you really need to distinguish between mains leakage and service line leakage. This becomes really important in areas like the Northeast and Michigan, where despite the fact that the curb stop or the Buffalo box where the shutoff valve is out near the street, the customer meter is actually inside the house. And although the utility may not own the service line, any leaks that happen on it essentially accrue to the utility because they're before the meter. Those are often very small leaks, but they tend to last a very long time. And I've seen many systems where their service line leakage is actually the greater portion of attackable leakage in their system. So those, I think, are two very good tools that you can use. and again, it's really a matter of just logging where the breaks are, how long they're running, recognizing that they probably ran for some period before they were discovered or you found them. Other things that I would really consider is, and the Water Research Foundation tool really gets to this, is really just distinguishing how leaks were found. Was it part of an active leakage control process? Was it done internally or externally? Because if you're doing a leak control investigation, you really want to know whether it's being cost effective. I know of a system here in New Mexico that used anecdotal evidence to come to the conclusion that they had a very leaky system, spent about 10 or 15 grand to do leak detection, and they basically found that they didn't have any significant leaks, and they didn't believe the results, so they did it again. So they basically poured somewhere between $20,000 and $30,000 down the tube, fixing the wrong problem. Their real problem was metering error. That's sort of a long way of saying start with a water audit and collect as much data as you can about the kinds of leaks that are happening in your system, and then make judgments based on the results. Because again, although it would be nice to get leakage down to zero or near zero, that's typically not possible, and what you're really looking for is an economically sustainable level of leakage. The third question that we got before, as part of the registration, was whether we'd ever worked with Utilis to do satellite-based leak detection. For those of you who don't know who Utilis is, they're a satellite leak detection company that's based in the US and Israel. They use an L-band synthetic aperture radar, which can penetrate a couple of meters of Earth, and they use some algorithms to basically detect the signature of drinking water and how it interacts with the soil, to identify points of interest that the utility can then investigate. I am in contact with one system out in Wisconsin that has done this, but I was not able to get in touch with them to find out about the results before this webinar. That being said, there are some case studies that Utilis publishes that seem to indicate that they've got about a 50% hit rate, so typically, or maybe a third to 50%. So if you get 100 points of interest, typically somewhere between 30 and 50 of those will actually turn out to be leaks. I know there isn't any pricing information on their website, and sort of talking anecdotally to other systems, I've heard that it can be quite expensive. That being said, little plug for partnership here. This is an area where utilities teaming together could really be beneficial. This particular system that I was talking about are near Green Bay. Green Bay's utility had decided to go with this, and I guess they contacted the smaller utilities around them to see whether they would be interested in piggybacking, because apparently the most expensive part of this is buying satellite time. That utility that I was talking about had 56 miles of pipe, and apparently they were able to get that swept and analyzed for about $4,500, which seems fairly reasonable. I don't know the results yet and whether they were satisfied with that, but that's sort of a rough cost estimate, assuming you were working with a larger entity. I think them doing it by themselves would have probably cost a lot more. And as Luke pointed out to me when we were talking about this earlier, this is not a replacement for acoustic leak detection methods or using correlators and things like that. What it really is a way of helping you focus your efforts on areas where leaks are likely to be, so that you can sort of cut down the time that you spend walking the pipe. Yeah, and it's basically looking for the leaking water, not the pipe. Anything else come in recently?
Yeah, so we can go back to the beginning of the presentation, and I'm going to be really impressed if you have this number in your head, but if you don't, we can easily find it. What was the WRS project number mentioned in the first half of the presentation?
4372A.
Yeah, you didn't write that down at all.
I have it written several places, and it is ingrained in my brain.
Okay, next question.
And the water loss model number is part of the same project. So if you look for Project 4372, you will get access to both spreadsheets. I would like to point out that the water loss model, which basically helps take the sort of bucket volume of real loss that the water audit gives you, because the audit does not break down your real losses in terms of, what's service lines, what's tank overflows, what's mainline leakage, what's background leakage. It doesn't do that. The model helps you with that. It was written a couple of years ago, and it doesn't work perfectly on some of the newer versions of Excel. So for example, we've got Excel 365, which I happen to be running on a Macintosh here, and some of the functionality does not work. That being said, if you've got an older version of Excel, it should be fine. I've been meaning to get in contact with the Water Research Foundation to see whether they're going to update that anytime soon. But it's really more sort of the graphical output that can be impacted by that. But it is a very good tool.
Can you repeat the code one more time, please?
4372. And we can actually send that out as part of the follow-up. I'll put it in the slides so that if you want to get the slides, you'll have that information.
Okay, this is a bit more of a specific question, but I think you could talk about it in general terms as well. What is a reasonable amount of leakage for a 50-year-old water system in a northern climate that has a ductile iron pipe?
The answer to that is that there is no specific answer, because there are a whole lot of variables that can impact that. Are you in an area that has hot soil or doesn't? That's going to have an impact. If you're in a northern climate, obviously you're going to have a lot of temperature swings and things like that. A lot of it is going to have to do with how well it was installed. That being said, the typical sort of reference number, and this is actually not related to leakage, this is related to the number of breaks, that is typically used for comparisons and is used in the Water Research Foundation tool is 0.2 breaks per mile per year, or 2 breaks per 100 miles per year. And even that is a big average number. It's assuming a lot of things, including a mixed pipe scenario with pipe of different ages. There are 2 studies out of Utah State done by Professor Stephen Folkman, one from 2012, one from 2018, that I highly encourage y'all to look up, that show pretty clearly that the US and Canadian average break rates for different pipe materials varies drastically. It varies to some degree from location to location. Within those geographic boundaries, it varies a bit by age and very significantly by type, although type and age do have some correlation. If I remember correctly, and I'm pulling these numbers out of my head, for cast iron, it was like 0.3 breaks per mile roughly, but for PVC, it was 0.02 something breaks per mile per year. So there's an order of magnitude difference there. The other piece of that question about what's a reasonable amount of water loss is directly related to how quickly you find the leaks and how quickly you repair them. And the range for sort of real-world leak detection and repair is very, very broad. I was doing some research on this and trying to come up with some sort of best practice times to maybe come up with like a repair time index. And actually, this was part of another Water Research Foundation publication that literally just came out about 2 months ago, but they had a table in there that showed some sort of best practices for repairs. And if I remember right, the city of Albuquerque, where we happen to be, the average time between repair detection or leak detection and repair is less than 8 hours. I think it might be 6 hours. There was one system in there that did it in 2 or 3. That being said, there are other cities that let things run for quite a long time. Sometimes that's the economically reasonable thing to do because it's a small leak, and sometimes maybe you've got a street repair project that's going to happen a few days later, and you would put off doing that, digging that hole and doing that repair. I think one of the numbers that I crunched based on the average of this most recent report was about 15-hour turnaround time would probably be reasonable. And then if your system has a lot of leaks, and you're losing a lot of money because of that. And you can take, societal and environmental considerations into play as well. Those are kind of the two numbers that you can look at. Obviously, if you're in a place like Michigan or Seattle, where I grew up, where water abounds, leaks aren't really as big a concern because there's not really a water shortage, and the water that's leaking out of your pipe is essentially costing you pumping costs and treatment costs, which overall are relatively low. If you're where we currently are now down in the Southwest, it's a completely different story. We get half of our water from the other side of the Continental Divide. There are, serious public problems or sort of image problems with letting leaks run, and we have water rights issues out here that folks on the East Coast don't have that can go into the problem as well. The report it's in the Water Resource Research Foundation. It is free and it is downloadable, and I do not happen to have a copy of it in my office, or do I? I will have to follow up with that. I'll include that in the slides as well. It's a very, very big project. I believe, yeah, and it came out a couple of months ago. I'm sorry I don't have that. I should have that on my desk, but I must have actually taken the report home to read at home for some reason. So,
that's good. We'll follow up with that one.
Yeah.
So we have about 4 minutes left. I'm going to ask one or two more questions that we have here. Are there any tools to assist in pipe inventory other than digging?
Yeah, actually, let me get my mouse to work here again. One of the things that you can do is go back to paper records. There are a lot of different sources that you can use. I'm trying to find a set of slides here that we have that kind of describes the typical process that we use for these small system mapping projects. We start with as-built quite often, and that's something that a lot of systems will have, at least in partial format. We have literally walked around with orange vests and collected data, and there's nothing like wearing an orange vest in front of somebody's house to get them to come out and talk to you. So we will get information from locals. There's a lot of different sources, talking to retired operators. In many cases, some information is better than none. And this is, again, one of the reasons why you really want to keep an ongoing log of breaks and other repairs, because every time you do dig a hole, you get some information about the condition of the pipe, what kind of pipe it is, what's there. And it's also important to remember that this mapping is kind of an ongoing process. It's never really going to end, because you're always going to be updating and fixing your systems. So there are ground penetrating radars and a lot of other things like that are available. But digging back into your paper records, one of the things that we did here in Albuquerque, and it was a heck of a job, was go back through all of the work orders and essentially digitize the important information and build some data out of that.
Okay, so let's make this the last question. Do you consider leaks due to rotting bolts on valves as breaks?
I would categorize those separately. In terms of a water loss scenario, yeah, they're breaks. There's water flowing out of the pipe. One of the things that the WRF tool does that I talked about before is that it lets you categorize breaks in a lot of different ways. And one of the categorizations it has is fittings. So if you were using that tool, rotting bolts on a valve would fall under the fittings category. So you would essentially be able to analyze those as part of water loss as a whole or condition as a whole, but then you would be tracking specific data about those, and I highly encourage doing that.
Okay. Well, for once, I think we've actually answered everyone's questions, and of course, we'll follow up again with the WRF information. But if you think of any questions after this webinar is over, feel free to reach out to any of us. Do you guys have any parting words that you'd like to say?
Yeah, I do actually. one of the biggest impediments, I think, particularly with small systems that I see is the idea that like this is, mapping is a really big job and it's really difficult and there's a steep learning curve. That being said, don't let what you can't do stop you from doing what you can. You can eat an elephant a bite at a time. And the idea is pick something that's important to you and work with that. One system we worked with, revenue was an issue for them. So the first thing we did is we started an inventory of their meters. And we found that about 4% of the meters that were out there and were active weren't in their billing system. That's instant cash in the back pocket, low-hanging fruit. That's where I would start. Understand that this is an iterative process, but if you don't start, you're never going to get anywhere.
Great. I think we're good to go, Tess. Thank you, everyone, for joining us.
All right. Thanks, everybody.